Hi, this is Shadi Atia, professor at Liège University in Belgium, and today's presentation is about correlation and causality in statistical analysis. Well, the presentation of today is a part of a playlist on observational research. I hope you watched previous videos, and I need to remind you that we are here focused in this series on observational research as part of the family of quantitative research, where we are looking at observational or correlational or statistical research methods. Now, the objective of today's presentation is mainly to learn how to distinguish correlation from causality and to learn about causality in general and how to measure it and how to prove it. Now, when we divide the different types of statistical tests, earlier we were talking that there's two main families, the descriptive statistics, and we are having the inferential statistics or the parametric statistics. We are here in the extreme right of the inferential statistics, which is a very advanced level of tests. When we are done and finished with the comparative and variance tests, that we move also beyond the clustering or the regression test, we are here in the correlation modeling test. So in this category, only if we have causality proved, then we can proceed with more advanced tests. Now, I'm going to talk with you today about an introduction. I'm going to present causality, correlation, and then spurious correlation, and then which is a kind of fake correlation. And then I'm going to talk shortly about how to do causality checks. And if you prove this causality, what should you do or how can you use your findings to predict and to model better the results or the expectations for your scenarios before some takeaway messages. Now let's start with correlation in statistics. Well, when we talk about correlation in statistics, we are talking here about significant linear relationships between two continuous variables or more. Regression, unfortunately, is confused with correlation. And in fact, correlation does not all the time imply causality. So we are so happy with this curve, and we find sometimes in our data some patterns and some correlation, but it doesn't mean that there is a causality behind it. Yes, we can have different correlation, positive or negative, that will range between -1 +1. We can test our relation between our different variables if they are two dependent, two independent, and one independent and one dependent. But at the end of the day, this correlation testing does not mean that I have a causation. What is then causality, and when can I come to this moment to say they have a causality? Well, causality will inform us of the extent to which a change in the independent variable will cause a change in the dependent variable with a high certainty. So this means that this relationship between the events or the variables in which one event or process causes an effect on the other is proved, and this is having an evidence from our tests and in reality. Now, how can we prove causality? You could use the correlation as your statistical test to demonstrate this high quality true relation, or you can do some experiment. You can repeat your test. You can divide your sample in two and apply the same test in the two samples and check if the causation is strongly present or not. And this will be always associated with calculating your confidence interval or describing in general your level of confidence, or if you are not so confident, the uncertainty. So I always invite you, when you are conducting or trying to prove causality, to use the p-value all the time. Now, like I said earlier, take care, because correlation can give you very good results, but in reality it doesn't say that there's a causality. We have a temptation that we think that one cause influenced the other as scientists, and the cause or the influence of the third variable or other factor that influenced the result could be used to prove causality. So causality can be proved by doing additional tests, using a third variable, which is not the only case, but the third thing which can help a lot is to understand things in a context and interpret the results in a wider and broader context involving human beings. So, like you can see here, ice cream sales are correlated to shark attacks, but we cannot say that the sales of ice cream are a cause of the shark attacks. So we find a lot of associations when we study phenomena, but we need always to be very critical. We need to contextualize our findings, check for other variables, repeat our observations to make sure that we establish this correlation. And therefore, I advise you to use the fishbone diagram. The fishbone diagram is a realistic way to better understand the complexity and the various causes behind a certain phenomena, so we can name the different causes and then we can come up to the effect. Because in reality and in practice, problems are so complex and we can hardly distinguish confounding parameters and separate and control the conditions of influence, meaning that in observation research we are not conducting experimental research. We cannot control the outdoor environment, which means that most probably we'll have a cocktail effect. We will have several causes that influence the effect. And therefore we need to have this wide way of thinking, use the fishbone diagram and establish these correlations and then start to see how those different variables influence the results. Now, allow me also to talk about a very important bias or important information of pseudo correlation, which is the spurious correlation. Spurious correlation is simply that I find an association or a correlation, and in fact, the multicollinearity suggests that the multiple factor influence the results, and spurious correlation in statistics is simply that we refer to a connection between two variables that appears to cause the results or the effect, but in reality there is no causal effect. So we need to be very careful about it. Another important bias or another important term to be aware about when you are trying to prove causality, that not only knowing about the spurious correlation, but to know also about the confirmation bias. Because we as human beings, we are very good at fooling ourselves, to stay in our comfort zone, to confirm our biases. And confirmation bias is simply a tendency to search for or interpret or favor or recall information in a way that confirms or supports one's prior beliefs or values. So as you can see, we can have some facts, we have some evidence, and then we have our belief, and then the intersection between them results to be falling in a gray area where we try to use our findings to fall within our belief pattern, and by that we are committing a big error by doing this confirmation bias. So knowing about the spurious statistics or the spurious correlation and knowing about the confirmation bias are two important errors or ways of thinking that we fall in, and we need to avoid them. Now then you can ask me, what is the way to check my causality? Well, this is point 4 here. We are talking about causality check. What can we do to check causality? First of all, you have to be very wary about this claim of causality. Like I mentioned earlier, you can add another variable to test the causality. You can interpret the results in a wider context. And the third thing to do is also to repeat your observations and change the chronological order of your observation and test if there is an influence of the second time measurement or of the change of the sequence of variable measurements on the correlation. Those are the 3 actions that you can take to measure or test or prove the causality. Now, once the causality is proved and you have positive confirmation that there is a causation and correlation, only then you are able to start to run a series of prediction and modeling tests. And here I'm talking about different regression analysis tests or techniques that will help you to determine not only the relationship between the variables, but it will help you also to move beyond the establishing of a correlation and interpretation of causation, but to go with a prediction. So the analysis will yield a predicted value for the criterion resulting from a linear combination of the predictors. And here we can apply different techniques like the simple linear regression. Non-parametric also can be in this case. You can apply simple and multiple logistic regression. And you can go one step further with advanced statistical tests, such as the log linear model or artificial intelligence-based methods for your prediction. Well, this is bringing us to the end of today's presentation. Allow me to share with you some takeaway message before leaving today's presentation. Well, every time we are doing statistical analysis, every time we must ask ourselves, what is the objective of my tests? And as you can see, we have 6 objectives. Number 1, describing the sample. Number 2, detecting variance. Number 3, comparing and testing hypotheses. Number 4, establishing correlation. Number 5, prediction. And number 6, proving causality. In today's presentation, I tried to explain to you how to check and prove your causality. And this is the purpose. I can only achieve, or I can come to this level, if I succeeded in passing all the previous objectives. I need to have first proof that there's a variance, first of all, making sure that my hypothesis is positively working, establishing a correlation, and based on that only I can move to the step of proving causality. When we talk about some takeaway messages for today's lecture, causality refers to a relationship between 2 events or variables. In general, be aware of the confirmation bias and spurious statistics, because the correlation does not all the time imply causality. If there is a correlation, it must first be checked whether the causality exists, and we talked before about different techniques. Make sure that the relationship must be plausible and precede the effect of time, and not only to the third variable, and for sure interpret your results within a wider context and within the context of the state of the art, and only based on that you can better prove the causality. Well, this was today's presentation as part of a playlist on observational research. I invite you to watch following videos that will come after. Today's presentation was about correlation and causality in statistics. Thank you very much for your attention.